All right, let's take a look at lesson 2.3.2, building atoms. It says, these are Bohr models for beryllium, fluorine, and a carbon atom. Again, the atomic structures have been enlarged. In reality, the radius of the nucleus is about 100,000 times smaller than the radius of the entire atom. So first it says, label the electrons, the nucleus, the neutrons, and the protons. So let's do some highlighting here. The electrons are yellow, and those are the ones that are outside the nucleus. The nucleus is the entire middle. The neutrons, let's do the protons first. The protons are the ones that match the atomic number. So beryllium's number 4. So that means that the white ones here must be the protons. And therefore the neutrons would be the black ones, which now I'm shading pink. And every single one of these atoms is neutral. Explain why. The number of positive protons is always equal to the number of negative electrons. So let's check out carbon, for example. This one has 6 of the white ones, so those are the protons. And it has 6 of the yellow ones, which are the negative electrons. So positive 6 plus negative 6 equals 0, which is what neutral means. How did you know which were the protons and which were the neutrons? So again, the white spheres are the protons, and we knew this because beryllium is number 4, and there were 4 white ones and 5 black ones. So, all right, 5 black neutrons. Because if it were number 5, it would be a completely different element. It would be boron. It's just the nucleus. Is just the nucleus part of these atoms positive, negative, or neutral? Well, the nucleus is just made of positive protons and the neutral neutrons. So overall, the nucleus would be positive. Again, because it's made of positive protons and neutral neutrons. So nothing's canceling out the positive charge. How do you figure out the number of electrons in a neutral atom by looking at the periodic table? It's the same as the atomic number. So whatever number the element is, that's how many electrons it has. How do you figure out the number of protons? Same thing. It's the same as the atomic number. But it's a little tricky to figure out the number of neutrons in the most popular atom because you round the average atomic mass to the nearest whole number, and then you subtract the number of protons, because protons plus neutrons always gives you the mass number. So how does the mass number of each atom compare to the average atomic weight? Again, it's usually very close. It's just a rounded version of the average atomic weight. But sometimes it's off. So sometimes atoms of an element can have a, how do I want to say this, a different number of neutrons or a variety of how many neutrons it has. Make a drawing of a boron atom. Boron is number 5, and its average atomic mass is 10.81, which rounds to 11. And then if we do 11 minus 5, we're going to know we've got 6 neutrons. So to do our little drawing, let's start with 5 protons in the center. And then we need 6 neutrons, so 6 of the black spheres. And then if we look at these, they all have 2 rings around it. So the first ring always has 2. And then the outer one has the rest. So in this case, it would be another 3 because it has a total of 5 electrons. So you can see we've got 1, 2, 3, 4, 5 electrons. We've got 5 protons. That comes from the atomic number. And then we've got 6 neutrons. And then let's use the periodic table to help us with the homework questions. So atomic number 18. Number 18 is argon. Oops. So this one would be argon. Has 3 electrons. That would be lithium, number 3. Has an average atomic mass of 16. That is oxygen. And then we need to complete this table. First, let's put in the names. These are elements that you should still have memorized. I don't remember if you had selenium, though. I don't think you did. That one's coming up. We've got nitrogen, sodium, selenium, strontium. And then you can use the periodic table to figure out their atomic number. Some of these I have memorized, so I'm going to write in the ones I know. Selenium, 34, and then strontium is 38. So obviously these are going to all match. The atomic number is always the same as the number of protons and the number of electrons if we assume the atom is neutral. And then the average atomic mass. So sulfur is 32.06, which means the mass number would be 32. That's the nearest whole number. And then 32 minus 16 to get the number of neutrons, 16. Magnesium's average atomic mass is 24.305, which means that it rounds to 24. And then 24 minus 12, 12. Nitrogen's atomic mass is 14.01. So 14 minus 7, 7. Sodium's average atomic mass is 22.99. Oops, I should have made that bigger, which rounds to 23. And 23 minus 11 equals 12. Selenium's molar mass is 78.96. And so that rounds to 79. So now we have to do math. 34, 44, 54, 64, 74. That's 45. 79 minus 34. And then we've got strontium, last but not least, is 87.62. 88. So we've got 88 minus 38. And that is 50. Sorry if I sound super tired in this video. I am. The twins were wild today. Thanks for watching.